Welcome back to History of Simple Things. Today's topic comes from one of our viewers, Munis Ahmad. Thanks for the suggestion. You asked, what exactly is Rockwool? If you've ever opened up a wall, looked inside a ceiling, or watched a construction video, you've probably seen this strange, fluffy material that looks like tightly packed gray fibers. It almost resembles cotton candy. If cotton candy were made out of stone, that material is called rockwool. So how does something as solid as rock turn into a soft, wool-like material used in buildings, soundproofing, and even farming? Stick around as we uncover the fascinating transformation behind rockwool, right here on History of Simple Things. The idea behind rockwool actually goes back further than you might expect. In nature, volcanic activity sometimes produces thin strands of mineral fibers when lava is thrown into the air and cools rapidly. Ancient people even noticed these natural fibers and used them in limited ways. But industrial rockwool didn't appear until the late 19th century. Around the 1890s, engineers in the United States began experimenting with melting rock and spinning it into fibers. Early production methods were messy and inconsistent, but the concept worked. By the early 20th century, companies had refined the process, and rockwool became a reliable insulation material. It gained major popularity after World War II when construction boomed and energy efficiency became more important. Since then, it's been widely used in buildings, factories, and even agriculture. At its core, rockwool is made from natural stone, usually basalt, a type of volcanic rock, along with recycled materials like slag from steel production. The process starts by heating these materials in a furnace to extremely high temperatures, often above 1,500 degrees Celsius. At that point, the rock melts into a glowing liquid similar to lava. Then comes the fascinating part. The molten rock is spun at high speeds, kind of like how cotton candy is made. As it spins, it stretches into thin fibers, which cool almost instantly. These fibers are then collected and compressed into mats, boards, or loose-fill insulation. To hold everything together, a small amount of binder is added, along with oils to reduce dust. The final product ends up looking like dense, fibrous wool, but it's entirely mineral-based. Rockwool's biggest advantage is its ability to trap air. The tangled fibers create tiny pockets of air, and air is actually a very poor conductor of heat. That means heat has a hard time passing through the material. In simple terms, rockwool slows down heat transfer. It keeps warm air inside during colder months and blocks heat from entering during hotter months. That's why it's commonly used in walls, roofs, and ceilings. Another major benefit is its fire resistance. Since it's made from stone, rockwool can withstand extremely high temperatures, often over 1,000 degrees Celsius, without melting or burning. This makes it one of the safest insulation materials when it comes to fire protection. It also doesn't produce toxic smoke when exposed to flames, which adds another layer of safety in buildings. Rockwool isn't just about temperature. It's also excellent for sound control. Sound travels through vibrations, and rockwool's dense, fibrous structure helps absorb those vibrations. Instead of sound bouncing off surfaces or passing straight through walls, the fibers disrupt and weaken the sound waves. That's why rockwool is often used in recording studios, theaters, and apartment buildings. It helps reduce noise between rooms and improves overall acoustic quality. If you've ever wondered how some spaces feel surprisingly quiet, even in noisy environments, materials like rockwool are usually part of the reason. You might assume that something soft and fibrous would absorb water easily, but rockwool behaves a bit differently. While it can allow water to pass through, it doesn't retain moisture the way materials like sponge or foam do. Its structure lets water drain while still maintaining its shape and insulating properties. This makes it resistant to mold and mildew, which is a big advantage in construction. Moisture problems can cause serious damage over time, so using a material that doesn't hold on to water is a huge plus. Interestingly, rockwool isn't just used in buildings. It's also widely used in agriculture, especially in hydroponics. In this context, rockwool acts as a growing medium for plants. Seeds are placed into small cubes of rockwool, which hold moisture and nutrients while still allowing air to reach the roots. Because it's sterile and doesn't contain soil, it reduces the risk of pests and diseases. Farmers and greenhouse growers use it to grow everything from lettuce to tomatoes in controlled environments. It might seem strange to grow plants in something made from rock, but it turns out to be incredibly effective. Is rockwool safe? This is a common question, and it's worth addressing clearly. Modern rockwool is considered safe when handled properly. The fibers are designed to be less harmful than older insulation materials, and they are not classified the same way as hazardous substances like asbestos. However, like many fibrous materials, it can cause temporary irritation if it comes into contact with skin or is inhaled as dust. That's why protective gear, like gloves and masks, is recommended during installation. Once it's installed and sealed inside walls or ceilings, it doesn't pose a risk to occupants. Rockwool is one of those materials that quietly plays a huge role in modern life. It's not flashy and most people never see it, but it helps keep homes comfortable, reduces noise, improves fire safety, and even supports modern farming. And perhaps the most fascinating part is how it's made. Taking something as solid and unyielding as rock, melting it down and spinning it into soft, flexible fibers, it's a perfect example of how engineering can completely transform a material. So the next time you're inside a quiet, comfortable building, there's a good chance rockwool is working behind the scenes, doing exactly what it was designed to do. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.